All right, we're going to get started right into 6.2, assuming that people got a bit of a breather. Here we go. We're going to look at graphing and calculating the inverse of exponents. This thing called logarithms. So let's pretend you don't know anything about it, okay? We're going in fresh. Suppose you made an investment of money known to double in value every year. I made this a long time ago when crypto was getting big. Okay, so don't worry about that. Blah. Time has an exponential effect on your money. Therefore, as time passes, my Y value increases, and that's money. And if this were to be some kind of graph, we have we would love our time to money chart to look something like that. Okay, and the steeper it is, the better, because you're making more money. What if you were interested in the relationship in the opposite direction? In other words, what if you're interested in how much money you would, if you want a certain money, how much time is that going to take? You would then use a money value to calculate the time value. It's an inverse. It is not easy to receive an answer and guess the question. So it is to our benefit if we calculate a new equation that gives us this. Anytime we plug in the money, I want the time that it takes, right? So if I plug in money, so right now it's time versus money, I want to know, like, if I had a question saying, okay, I want a certain amount of money, like I want this much money, how much time did that take? I would look at something like something like that. Okay, wouldn't that be great? Okay, is it always necessary? No, but there are some times where you do want to know, if I want this as my answer, what is the question, right? If I want this to be my final, what do I have to put in? Like, there are times where that's, in fact, what most real life questions are like. Okay, so here is the challenge. Right now, we have a function, y is equal to some base to the power of x. What I want is, how do I get the inverse? I want to know, if I have the answer, what's my question? But the problem is, how do I isolate the y? You don't know, right? So what we're trying to do is, the bordered equation states, to produce x, the base must be raised by an unknown amount of time. But it's really inconvenient to do it this way. It is a lot more easier to express the y in terms of x. So we have to isolate y. How do I get y all alone and drop down the exponent? And what do I do with the x to make it input it into somewhere? We are introducing a new function called a logarithm. Logarithm of the same exponent base that we were using. So the bordered equation above here, we call it y is a logarithm of x using base b, or base 2, or base whatever. Okay? In simple arithmetic, it's, if the answer was x, what is the exponent with a base of 2? Let me try to explain. Okay, so if this is, so some base to the exponent gives us the answer. By inversing, this is what it is. Log, using the same base, if you're given the answer, what was the exponent? That's what we're doing here. Okay, so here, for example, same thing. 2 to the power of 3, what's the answer? 8. Well, log of base 2, if the answer was 8, the exponent must have been a 3. Right? Base of 5, exponent of 2, 5 to the power of 2 is 25. So using a base of 5, a logarithm of 5, if the answer was 25, the exponent must have been 2. We're always going, if it was, here's the question, there's the answer. If that was the answer, what's the question? Sort of like that. Okay? And no, the base doesn't have to be a 2. As you can see, it can be a 5. The most typical base is 10. So you know that 10 to the power of 1 is 10. 10 to the power of 2 is 100. And 10 to the power of 3 is 1000. That's great, right? But here's where the logarithm really gets handy. Let's convert. Log of base 10 is equal to, where the answer is 10, the exponent must have been 1. Log of base 10, if the answer was 100, the exponent must have been 2. And the log of base 10, if x was 1000, the exponent must have been 3. Now please note, because log of base 10 is so common, your calculator doesn't have log of base 10, it's literally just log. By default, log with no number means the base is a 10. So if you're on your calculator, if you find log and you plug in log 1000, your answer should be an exponent of 3. But why is this useful? It's useful because you can find answers that are in between. Like if I did 10 to the power of 2.5, that's a number between 100 and 1000, right? If you did 10 to the power of 2.5, you can figure that out. And in fact, that number is 10 to the power of 2.5. That is about 316.227766, so on and so forth. But what if I did this? What if I didn't know what that was? And I'm like, hey, what exponent do I need to get an answer of 316.227766? You do a logarithm in the calculator and you will get approximately 2.5. That's the usefulness of a log. If this was my answer, what was the exponent? Super useful. So let's try it. Okay? Again, rewrite the equation in logarithmic form. Please just consider, okay, this is my answer, right? This is your answer is equal to base to the power of some exponent. And so by logarithm, we would like log of the base. If this is my answer, this must have been my exponent. Okay. If I might ask the substitute teacher or the on-call teacher to pause the video, I'm going to ask everyone here to try these two without a calculator. Just rewrite it in logarithmic form. Okay. Try it now. Assuming you've tried it and it was paused and we're going on, the correct answer would be log of base n. If the answer was 4, the exponent was answer was m, the exponent is 4. Log of base 3. If the answer was 1/9, the exponent must have been -2. Okay. Case in point, all these examples that I give you from here on out, most of them will have some agreement. We'll have some way of relating the base and the answer. And I'd like you to try this using your multiplication skills and not the calculator, because your first quiz, 6.1 to 6.3, early next week, you can't use a calculator. Dun, dun, dun. Anyways, here we go. So for here, if you think about it, without a calculator, eh? So this is like 3 to the power of something is 81. That's what this logarithm is. Well, isn't 81 the same as 3 to the power of 4? 3 times 3 times 3 times 3? What does that mean? That means the exponent must be 4. Log 81 with a base of 3 equals 4. Same with this. What am I looking for here? Well, I do know if a log is a base of 2, the exponent is a base of 2. And whatever the exponent is, or the base 2, whatever the exponent is, I got 1/8 as my answer. And well, you know 1/8 is the same as 1 over 2/3, 2 to the power of 3, which of course by reciprocal exponent laws is -3. The exponent is -3. So the answer to this is -3. I consider this totally doable. You just need to get used to logarithms. Same here. Base 10, some exponent gives me 0.01. And if you remember, maybe you want to do your percents, that is equal to 1 over 100, which is 1 over 10 to the power of 2, which is 10 to the power of -2. X equals -2. There it is. Same with this. Consider practicing this. I will fill this answer in and put it up online, but you can move on. So the summary of this, I really want you to do as many questions as is possible because it will absolutely help you with your quiz. I must implore you to, without a calculator, do as many of these questions without a calculator to be able to switch between exponential function and logarithmic function and vice versa. The point of the lesson is this. If my exponent function is something like this, right? Y equals, I'm going to do f of x, sorry. F of x is equal to b to the power of x. Then it's not just a reciprocal function anymore. We can label it. This function, yes, it's a reciprocal, but it's actually log of base b x gives me a y. Okay, and I'm going to call it inverse of x. So this and this are related to each other. They are inverses. And that's wild. Okay, there's so many amazing, useful applications for knowing log. It's because they are related. For every exponential function application you know, whether it's money, whether it's radioactivity and half-life, okay, whether it is doubling period like bacteria, anything, okay, zombie COVID apocalypse modeling, anything. There's just as many applications for logarithm. Okay, so there's a lesson. I really hope you'll get a chance to practice this. Go straight to this to see if you can work through it without a calculator. That's the biggest stress. Okay. And test your mettle. And once again, I'll see you tomorrow, so suffer well. And if you have any questions, email me or hold it until the next time I see you. All right. See you soon.